This video is going to focus on some aspects of radiation related specifically to the greatest factors impacting exposure, as well as some workplace regulation ideas and some of the signage that goes along with those. And then finally, some uses and common places where we find radiation on a more regular basis. So when it comes to looking at exposure and kind of the factors that impact whether or not exposure is going to be damaging or not damaging or how impactful it's going to actually be, there are four factors that we really need to look at. The first is the type of radiation. So is this something that is an alpha emitter? Is it a beta emitter? Is it a gamma emitter? And that goes hand in hand with the second thing, which is the energy of the radiation. Obviously, higher energy forms of radiation are going to be much more dangerous than lower energy forms of radiation. But included in this also has to be the idea of half-life. How quickly does this radioactive material actually decay? Are we talking about something that has active decays every few seconds, every few milliseconds, every few hours? Each of those are going to have a much bigger impact on the overall exposure and what kind of issues we're going to see overall. The other two factors have to do with specific isotopes. So if we're talking about, for example, a isotope of iodine, it's going to have a very particular target in your body if you happen to ingest it, because iodine tends to congregate in your thyroid gland. And so if you have radioactive iodine, that radioactive iodine will find its way into your thyroid gland as well. And we can kind of target it for that kind of thing as well. The last factor is age. And we'll talk about that a little bit here in just a second. So when we talk about specific radioisotopes, what we have to understand is that certain types of radioactive materials are going to have have very specific kinds of impacts on your body. So, for example, strontium and radium are well known to cause leukemia, and exposure to each of these is going to increase one's risk for leukemia just by simply being exposed to it. As I mentioned before, iodine radioisotopes tend to congregate specifically in your thyroid gland. And so their impact is going to be much more significant on your thyroid than it will be to other parts of your body. Now, when it comes to age, what we have to worry about more specifically is the idea of mutations. We know that certain materials are going to impact your DNA much more effectively and significantly than others. And so DNA replication becomes a much more serious, considerable issue. And that affects the young much more so than does the old. Because younger children have more cell replication, they're growing, they're dividing more cells, they're growing more cells, they're getting bigger, they're creating more cells. And as a result, if a mutation does occur, that is going to be propagated much more frequently in a child than it is in an adult. And so, unlike what we see for a lot of illnesses and effects where we tend to worry about the very young and the very old, this is an impact where we really only look at the very young children, especially those who have not reached the age of maturity, where they are still growing and still changing in their bodies and everything as well. Now, since you are not children, what about when we get into the workplace? And so workplace regulations are a little bit different. Now, workplace regulations, OSHA requires that certain types of signage be put up. Now, I'm going to tell you, the signage that they require that be put up is something that is definitely conspicuous, something you'd be able to tell very quickly whether or not radioactive materials were present or not present. And so there are three types of signs. There's the sign for the radiation area, there's the sign for the high radiation area, there's an airborne radioactivity area where we have to worry about airborne radioactive particles as opposed to just solid or liquid. But as I mentioned, the signage here, incredibly conspicuous. Bright yellow with magenta. You've got the trefoil symbol here to indicate that it is radioactive. You've got the magenta signage here. Very bright, very easy to see. And so the primary difference, you've got radioactive material, you've got radiation area, signage here, practically the same coloration, same everything. As the danger increases, there are some cues. So a highlighting cue here to indicate that we are in a high radiation area as opposed to just a radiation area. And then for airborne radioactivity area, we also have the word danger. So again, the use of those signal words. Caution gives us a idea of the danger, of how significant the situation is. Danger is an increased amount of caution, an increased amount of danger that is associated with this particular area. So we have to be extra careful in those kinds of areas, and especially if we have something that's airborne. Then we're talking about much different kinds of personal protective equipment. We're talking about self-contained breathing apparatuses. We're talking about those kinds of things to keep the workers safe in those areas. Now, there is another sign here, the grave danger, very high radiation. This is not one that is regulated as much. The wording here obviously indicates a heightened awareness, but it's not as common to see this one. This isn't one of the ones that is often as required. Occasionally you might come across it, but it's not nearly as noted as the other ones that we've shown so far. Now, what happens when you encounter radiation? Well, the primary action of any kind of radiation is that it ionizes you. And what we mean by it ionizes you is it starts to rip electrons away from your cells. And your cell's response to that can happen a number of different kinds of ways. It can simply die. Um, it can impact certain body systems like metabolism or biochemical processes that are similar. It could also damage your genetic material. And in damaging the genetic material, again, the cells could die, they could mutate, they could start rapid reproduction and other kinds of effects similar to cancer. Um, and so that's our primary action of radiation. That's what usually happens. And that's why we have to be really careful and considerate of the types of radiation that we are encountering and knowing, okay, are we talking about something that is alpha or beta? Is it alpha or gamma? Is it beta or gamma? What is it that we're talking about? Because as we all three of the forms are ionizing. However, not all three of the forms behave exactly the same way. Some of them are more disruptive than others. Now, some common uses for radiation, probably the most common one that we know of is medical imaging. Medical imaging, we can use radioactive isotopes in a number of different ways. And we can use them because when we put the radioactive material into our bodies, it will continue to be radioactive. It'll continue to act in your body the same way it acted outside of your body. And so, if we're careful about what isotopes we select, we can actually track them through different parts of our body and use that to pinpoint certain types of problems. And so, the most common ones that we find, gadolinium 153, which is used in SPECT imaging, um, low molecular weight, odd numbered isotopes of carbon, nitrogen, and oxygen. Any of these can be used in PET imaging, positron emission tomography, um, and that positron emission coming from, these are all beta decay experts. They're all really good at beta decay, and will actually emit positrons as they do. Now, why these ones in particular? Well, it's because of this. They are low-level radiation releasers. You don't need to give a patient very many of these, and it'll give pretty consistent results, and it has a short half-life. So it's not going to be in your body for very long. But the results that they give are pretty spectacular. SPECT imaging is often used in brain imaging. PET imaging is often used in other types of imaging. In this particular case, um, a gastrointestinal kind of look that was able to pinpoint this piece right here. This is actually a tumor on, I believe it's the lung. Of this particular patient. And so PET imaging was able to predict that because we had an abundance of tissue here where we weren't expecting it. And so the imaging, the radioactive isotope was able to light up this aspect of the image, and the radiologist was able to find it and start to think about treatment. Now, the other big common way that we experience radiation is through radon. As I mentioned on the previous video, radon is what is responsible for a little bit more than a third of most people's radiation exposure in a given year. And the reason why we can't help it is because radon is a derivative of the decay of radium. And radium is found naturally in a bunch of different rocks underneath the surface of the earth. And what happens is that those radium atoms will decay, and as they decay, they produce this colorless gas, this odorless gas that we know as radon. Now, radon can find its way into our house in a number of different ways. And so where we tend to find radon the most often is in our residential applications, in our house. Now, there are good home tests out there for radon. If radon is a particular danger in your area, it's something that you want to try to mitigate, try to be aware of, because you are increasing your exposure to radioactive materials with every breath. But for most people, these are all examples of where it can come from. For most people, most houses don't have most, if not all, of these sources. And so our regular encounters with radon are just based on the air we breathe, and the radon gets into the air we breathe because, well, it's a gas, and it sticks on the lower parts of the atmosphere because it's a heavy gas. It's one of the heaviest gases. So long as the concentration of radon in the air is relatively low, it poses very minimal risks. However, if we are in a situation where radon is in an elevated kind of situation, where we have higher than normal kinds of concentration of radon in the air, especially in the air surrounding our homes where we spend the majority of our time, that's when radon can be a particular risk. And if the concentration of radon becomes so high, then we start to move it into that inhalation health hazard area where we can start talking about air poisoning and radiological effects of being exposed to too much radon. So that's the end of this video. Our next video, and it's the last video out of our look at radioactivity, is going to talk about nuclear fission and the applications of nuclear fission that we're most concerned about and the most aware of, and that is nuclear power plants. And so I'll look forward to talking to you then.